Guys, so this is the lecture series on artificial intelligence, and you all know that artificial intelligence is a very emerging area in computer science. Not only the computer science is a means you can say the mix up of different domains, different areas. Okay, so we have already covered a lot of lectures in artificial intelligence. If you have not gone through them, then I am giving the links of the playlist in the description box below. Go through it. Okay, and today I bring a very important algorithm in artificial intelligence, and that is A star algorithm. Okay, so guys, if you have not already subscribed this channel, then do subscribe it, because in that way you can contribute towards the free knowledge sharing through this channel. Okay, and also share with your friends. So let's start today's class. So A star algorithm. In the last lecture, I have gone through best first search algorithm. Okay, so A star algorithm is the most commonly used best first search algorithm. Even many times it is asked in the exam that A star algorithm is a modification of or improved version of what algorithm? That is best first search algorithm. Okay, now important fact, one more important fact regarding A star algorithm is that it totally works on the basis of this function, okay, fn, and this will give you the estimated cost of cheapest solution, and that fn is equal to gn plus hn. Okay, and the together at this fn is equal to gn plus hn is also known as fitness number. Do remember the term? Because you know, in my lectures I only cover the important facts, both with respect to your semester examination point of view and also different competitive examination point of view, and they are frequently asked in the exams and interviews. Okay, so do note them. So fn is equal to gn plus hn, that is known as fitness number. And what is gn here? Gn is the cost to reach node n from start state. Obviously you will begin your search from a start state, isn't it? Then from that start state to your current state, okay, say current state is our n, this cost is our gn. Got it? And then what is hn? Suppose you are at this state and from there you will travel towards the goal, and that will include some cost, and that cost is known as our hn. Okay, cost to reach from node n to goal state. Clear? So fn is equal to gn plus hn. So if this is clear, now I am coming to the algorithm part, and you can take a screenshot of this algorithm. Okay, clear? You have taken the screenshot. Now I'll start explaining the steps. So sorry, step 1, you know, algorithm has some definite protocols. Protocol in the structure means if this is the algorithm, you need to give the name of the algorithm, and under bracket you may put the required parameters to be used in that algorithm. Okay, so the step 1, place the starting node in the open list. From the last class you got that we have two lists. We are maintaining two lists. One is open list and another is closed list. Okay, open list consists of those nodes which are not yet evaluated. Got it? Not evaluated means we have not yet generated the successors of that particular nodes. Okay, so those are our open nodes, or those are nodes in the open list. And closed nodes means which we have visited, we have expanded. Okay, means successors have been generated, they are closed in closed list. Clear? So these things are already discussed. Okay, then so step 1 says that place the starting node in the open list. Then step 2, this step is clear. Step 2 is check if the open list is empty or not. If empty, then return failure and stop. Okay, now if open list doesn't have any node, then how could we conduct the search? Okay, we can conduct the search when we have some nodes. We have some nodes to visit and evaluate. Okay, if there are no nodes in the open list, there is no other option left to terminate the search. We need to terminate the search and we need to print failure. Clear? So step 2 is very clear to you. Then step 3, select the node from the open list with lowest. See, I am underlining some words and those are the important words here. Okay, we are going to select that node with lowest fn value. We will have we have more than one node in the open list. Okay, we may have more than one node in the open list. Then if it is more than one, then we'll select only that node which has a lowest value for this fn. Clear? If it is the goal node, if that node we have selected itself is the goal node, then what we will do? Of course, our search is success, isn't it? So if this is the goal node, then return success and what? Stop. Okay, so we got the goal node and we'll stop. If it is not the goal node, then we will come to the step 4. So step 3 is clear. Now coming to the step 4. If this is not a goal node, then what to do? Then we'll expand that node n, okay, and generate all its successors. Generate all its successors means we are generating the children of that node and put that node n into the closed list. Of course, if n is picked up from the open list, okay, it is not yet been expanded. It is not yet been expanded means we have not yet generated the children of it. When we picked it up, when we have generated its successors, then this means what? We have to put n in the closed list. Got it? So we'll put n in the closed list. Now, suppose n will have several successors, maybe 1, 2, 3 like that. So suppose I am naming one such successor as what? N dash. Then for every such successor, for each successor n dash, check whether n dash is in the open or closed list. If not, then compute fn dash and place it in the open list. Now you will wonder, what does it mean? It means that we have generated that successors and we have found n dash one of that, and if that n dash is already in the open or closed list, then there is not a problem. Means open list means its n dash values being already generated. But if it is not in the open list, then what would happen? We need to find out that value fn dash. And when we have found out that fn dash values, fn dash means is equal to what? Gn dash plus hn dash. Gn dash is the value, means cost that is taken from to reach that n dash node from start node, and hn dash is the value to reach the goal node from our successor n dash. We have to calculate that value because our A star algorithm is totally dependent on that value. Okay, so we'll calculate that fn dash value and put that n dash in the open list. Got it? So this step 4 is clear to you. Okay, then step 5. Step 5 says that if n dash is already in the open list or closed list, then what we will do? Then it should be attached to the back pointer reflecting lowest g n dash value. Okay, this is again a typical step. What does it mean? So in that case, when it is already in the open or closed list, then what we'll do? We'll attach a back pointer to reflect the lowest g n dash value. Lowest g n dash value means what? To reach that node, successor node n dash from the starting node. Because we may have different branches. Suppose this is the say successor, we will reach that successor from different path. But we need to attach back pointer to only that path which will include a lowest value or lowest cost value. Okay, so this thing is clear to you. Okay, got it? So if still any doubt exists at any of this step, then do ask me. Okay, so this step 5 is clear to you. Then step 6 means if this process will be continued, so we'll go back to step 2. Check means if that open list is empty or not. If it is empty and we have reached the goal node, it is okay, very fine, means we have reached the goal node, we have found out the searching node. Okay, but if it is not, if it is empty but still we have not found the goal node, then this means what? Our search is failure. Okay, clear? So these 6 steps involved in our A star algorithm. Okay, and it's very important. At every step we are calculating some facts which are based on this function fn is equal to gn plus hn. Now I will consider one numerical problem or numerical example for A star algorithm. So look at here. Okay, is this picture clear to you? If it is clear to you, take a screenshot. Okay, we'll go through it and we'll explain the A star algorithm on it. I'm rubbing it. Okay. Now what happens, this graph is given to you. S is the search start node, then other nodes like S, A, B, C, D, Z. So of course Z is what? Z is our goal node. Okay, Z is our goal node. Now by applying A star algorithm, we need to find out the path to reach the goal node. So you'll see that at every edge, some values are there. Some values are there means what? Suppose from S to A. Well, suppose for example, you are at your current city, whatever your current city. For my case, Jorhat is my current city, and to reach Guwahati, Guwahati is 3 kilometers away from Jorhat, a city, okay, a major city in Assam. So to reach Guwahati from Jorhat, what happens? It will take an average of 6 hours, isn't it? So an average of 6 hours plus other costs also involved. So I am considering the best possible way, because to reach Guwahati from Jorhat, we have different options. We can hire some private vehicles, or we can we have our own vehicle, we will go through it, or we will go by bus, or we will go by train, or we even consider flight for that. But as per the cost is involved, or as per the less time involved, I found that using the own vehicle is the best possible way for to reach Guwahati from Jorhat. So that will involve 6 hours of time. So you have seen that from Jorhat city to Guwahati city, if they are considered as node, and this edge is joining Jorhat to Guwahati, will involve some cost. Say that cost I am writing as 6 plus 1 is equal to 7. Got it? Just giving you an example to understand these facts. So similarly, in this graph also, S, A, B, C, D, Z, we have what? Some values involved. Some S to A, 1, A to B, 2, A to C, 1, B, C to 4, C to Z, 4, like that. Okay. Then one table is given with the value Hn. What is Hn? Okay, got it, correct. Hn is the cost involved from current state to reach the goal state. Okay, so now how to find out the goal node? So through A star algorithm, it will involve some iterations. So first of all, our initial state is what? S5. Okay, how S5? Because if you are S star S means start state, then Hn value is 5. Now iteration 1. Iteration 1 means what? From S which nodes are connected directly? A and Z. So S to A, how much cost involved? S to A is equal to 1 plus A to goal node. How much cost involved? 3. So if this is the case, then 1 plus 3. how much value? We have got 4. That's why I am writing as S to A 4. Similarly, S to Z 10 and Z to Z of course 0. If you are already at goal node, it will not again cost you any other cost to go to the goal node itself, because you are already at the goal node. So Z to Z is 0. So 10 plus 0, S to Z means 10 plus 0, that is what? 10. So that's why I am writing as S to Z 10. Clear? Then iteration 2. Now from A, which are the nodes we can reach? A to B, B to C, A to C, like that. So S to A, A to C. One possible condition. Can you tell me how much cost involved? S to A to C. S to A 1 plus A to C how much? 1. But if you are at C, then how much cost involved to reach the goal? From the table 2. So 2. So how much cost? 1 plus 1 plus 2, that is 4. Clear? So that's why I am writing S to A to C, that is 4. Similarly, S to A to B, you try to calculate it by yourself. Okay, S to A to B, 1 plus 2 3, and B to goal node, how much cost involved? 4. So 2 plus or 3 plus 4, that is what? 7. Okay, then S to Z 10 is already there. Then this is the iteration 2. We have not yet reached the goal node. Okay, although S to Z is the goal node, but it is involving higher cost. So we need to evaluate the other nodes also. Then iteration 3. Then iteration C, if we are at C, which are the nodes we can go? We can travel C to Z, C to D also. So we are considering S to A to C, C to Z. S to A how much? 1 plus 1 plus 4. 1 plus 1 plus 4 how much? 6. So this cost means S to A to C, C to Z, how much cost involved? S to A how much? 1, A to C 1, C to Z 4, and Z to Z, Z is from Z to Z itself, that is Hn is equal to 0, that is 6. So this path is giving you the goal node at the cost of 6. Similarly, S to A to B, B can be also be reached from here, and B to D, that is 1 plus 2 plus 5, how much? 8, and from D to goal node 6, 8 plus 6, that is 14. We are not going to consider it, of course, that is higher value. And then S to A to C to D, how much? 1 plus 1 plus 3. So 2 plus 3 5, and D to goal node 6, 5 plus 6 11, and other S to Z 10. Now at this iteration 3, you have seen that this part, this particular part, S to A to C to Z, we have got the goal node at the cost of 6, and at this iteration S to Z is 10. If we compare them, which one is the least cost? Of course this one. So according to the A star algorithm, or as per the A star algorithm is concerned, we have got our goal node at the cost of how much? 6. So A star algorithm will return this part S to A to C to Z. Is this clear to you? Okay, do one thing, you have already taken the screenshot, so you try to solve it by yourself, and if any confusion occurs, then do ask me. So this is the A star algorithm. We have covered a numerical problem also, and some other important facts that I want to tell you about A star algorithm is that A star algorithm is complete by nature. You may note it down. A star algorithm is what? Complete. Can you tell me what does it mean by complete? Of course, if you have attended my previous lecture, you can easily answer this question. Here, complete in the sense what? Because branching factors is complete. Branching factors means this is the node. What are the successor, or what are the childrens, the number of childrens you can generate from that node is the branching factor, and that is finite here. So and other thing is that the cost involved for the heuristic based experience is also finite. I cannot say that from our current city to to a different city, suppose 300 kilometers away, is infinity. I cannot say that, because it is very obvious that it will involve a finite cost amount. Okay, so that's why it is complete. Second, as it is complete and it is trying to find out the better possible value by considering this function fitness number, so it is optimal also, as the sorry, admissible conditions are given, so this is optimal also. So A star algorithm is complete by nature and optimal by nature. So these can be taken as the advantages of A star algorithm. Well, if they are the advantages, and one more advantage is that if there is a goal, then it is obviously going to find it out, okay, in the best possible way. Now, if they are the advantages, what will be the disadvantages of our A star algorithm? If you have attended my previous classes, you know that if some advantages are there, we always try to find out the disadvantages also, because in that way the science deals with it. Okay, we are the computer science students, we are the computer scientists, so we need to find out the worst cases also. We need to criticize an algorithm also. In that way also only some improved versions may come out. Okay, so disadvantage is that you have seen that this algorithm is totally based on what? Heuristic value. If heuristic values are considered from what? From the basis on the expertise knowledge about those conditions or about those facts. If that is not good, if that expertise is not correct, then obviously we are not going to get a good heuristic value, isn't it? So that is one disadvantage. And second is that this algorithm is storing that nodes, okay, that means visited nodes, then in the memory. If there is a very big graph associated, then obviously it is going to increase the memory size. Okay, memory means overloading will be happening, means we'll need a big chunk of memory to store those nodes. Okay, so that is again a disadvantage of what? A star algorithm. So you got the disadvantage, big chunk of memory may be required. So it is not good for a big scale problem. Big scale means big scale problem where the graph is very containing a maximum of 1000 nodes, or not maximum actually, it is containing more than 1000 nodes, like that. Okay, for big graph it is not suitable. So that is the disadvantage of A star algorithm. So you have noted them down. Okay, so now one important fact, again I want to tell you that about the complexity. In this case, the complexity of A star algorithm, both in case of time and both in case of space, that is our big O of b to the power d. What is b? B is the branching factor. And what is d? D is the depth of that graph. Okay, so you have seen that this is exponential, and if it is exponential means it is highly complex by nature. So that may again one disadvantage of A star algorithm. So guys, these are the facts about A star algorithm. I hope you have got every point and every concept that and the numerical problem that I have discussed in the class. One question I want to give you, which you have to answer through comment. And the question is whether A star algorithm is optimal or not. Okay, you need to comment that whether A-star algorithm is optimal or not. So I'll respond to those comments. Guys, so I hope you have enjoyed this lecture, and if you have really enjoyed this lecture, then don't wait, just press the like button. Okay, so we'll meet in the next lecture. Till then, take care. Bye bye.